Ngalakin Khadijan Nyunga Boja.
Good evening. I think most of you know me. I'm Karambod Siddiq, the director of the UWA Institute of Agriculture. And it is customary that the university acknowledge it is situated on the Noongar land, and the Noongar people remain the spiritual and cultural custodians of the land and continue to practice their values, languages, and beliefs. There are some familiar faces. I was just telling Simon, a lot of them are very keen on animals, so they are animal related, and I'm not wearing a tie today. Graham Robertson just said, is it because you are with animal production people? Yes, that's the reason. We don't have Phil Werko here. When he will come in shorts. I just would like to acknowledge here Dr. Graham Robertson, Emeritus Professor David Lindsay, and of course now Emeritus Professor Graham Martin, that first time I'm mentioning you since you became Emeritus. Dr. Bruce McIntosh, and of course distinguished guests, colleagues, students, ladies and gentlemen. Again, on behalf of the University of Western Australia, I wish to welcome you to the 2021 Alan Sevier Memorial Lecture. So I'll talk about a little bit about the history because Bruce did a lot of work on that. Alan Richard Sevier was a Western Australian farmer, particularly a place called Wilgoin, inventor and an amateur scientist. Before he passed away in 2013, Alan expressed a wish that his notebooks, a journal and writings on cattle reproduction and pheromone experiments are given to the University of Western Australia. I remember I was still the director of the UWA Institute of Agriculture, and we had to go through this process. How do we get that to the university and how we keep that? In his will, he also bequeathed funds to establish and run the Alan Sevier Memorial Lecture. So it took a while for us to accumulate the interest from that bequest fund to run the first lecture. So this year marks the second Alan Sevier Memorial Lecture. The inaugural event was held in 2018 and delivered by Dr. David Johnston from the University of New England on the topic of beefing up with the West and the genetics. And in fact, that is the beginning of the beef work, and now Phil Werko is leading a large Northern Beef Alliance, Northern Beef Link, and probably that was the beginning of that beef project. Until very recently, there was little documentation on the life and achievements of Alan Sevier. With the help of a bequeathed material and speaking with those whom he knew, UWA's adjunct associate professor Bruce McIntosh embraced the challenge of writing the biography of Alan's life and achievements, which he completed in late 2020. That was an assignment for Bruce during the COVID era. And he did a fantastic job. And I'm very pleased to say that this biography was recently published on the UWA Institute of Agriculture website. You can follow that link or QR code to read it at your own time. So I would really like to acknowledge and thank Bruce for his hard work and dedication in writing this biography. Thank you, Bruce. I'm now very pleased to introduce Associate Professor Simon D. Graf to deliver our 2021 lecture. Associate Professor D. Graf is recognized worldwide as an expert in sheep reproduction and artificial breeding. His research program have been awarded more than 4.5 million in funding and produced 75 refereed articles in the international journals, as well as 2 highly regarded book chapters on controlled breeding of sheep. He is currently, again, Associate Professor of Animal Production at the University of Sydney, Secretary General of the International Congress on Animal Production, and a regular consultant to the artificial breeding community, the sheep community. Simon will deliver the Alan Sevier Memorial Lecture on the recent advancements and upcoming work that will underpin the future of sheep artificial breeding. Simon did spend this morning with some of our PhD students at a one-to-one interaction. Welcome, Simon.
Thank you very much, Steve. Thank you to all of you for coming out to see me. I am very humbled that so many people would take time out of their day to listen to me speak. I was trying to explain to my 5-year-old yesterday or the day before what I was doing. I said I was going over to Perth to give a talk. And he said, "Is it just you giving a talk?" I said, "Yes, people are just coming to hear me give a talk." And he looked at me, he's like, "Why, Dad?" Why? And then he asked whether people in Western Australia also spoke English. I said, "Well, it's a lot of this." I am very excited to be here. It's the first time I've been out of the state in 14 months. It's also the first time I've left the house since our third child was born 7 weeks ago. So I had an excellent night's sleep last night, and I feel like I should be firing on more cylinders than I have been for a little while. So when I was asked to give this presentation, I was given the guidance that I could pick anything that I wanted to speak about. It's very rare that I get to speak about artificial breeding in sheep because we tend to fall into this funny niche category in many of the conferences that we attend, where we are either too applied or maybe we're in some places where we're too basic, or it's too niche. So it's a pleasure for me to be able to speak about this. The things that I want to really discuss with you this afternoon, because I think that there is a diverse background of people within the audience. Before I talk about the future of sheep artificial breeding, I want to speak a little bit about the current status and even just a fraction of the history. And then I want to speak about what at least I perceive as the threats to artificial breeding for the sheep industry, and then speak about some of the research which we have been doing or want to do to address some of those threats and secure artificial breeding for sheep, and thus this ability to facilitate more rapid genetic progress, secure that into the future. So when we think of sheep artificial breeding, there's a number of different technologies which that encompasses, but the one that most of us think about is this. This is laparoscopic intrauterine artificial insemination. And what most of the students that I teach take away from artificial breeding of sheep is that sheep are upside down whilst this is occurring. There's a good reason for it. It's not because, as somebody has said to me before in class, I'm just a cruel, cruel man. That has not got anything to do with it whatsoever. This laparoscopic artificial insemination came around in the early 1980s. We'll go into the history of that before, but the important thing for you to note about this is that it is delivery of frozen semen usually, although there is some fresh semen which is still delivered by this means, directly into the uterus using a laparoscope and various other bits and pieces of surgical equipment. There are other reproductive technologies which are utilised by the sheep industry, so MOAT, or multiple ovulation embryo transfer. It's linked in a way. It's still, you have artificial insemination, but you just have ewes which have been superovulated prior to that AI, and then you get lots of embryos out. There is also something referred to as GIVIT, which you superstimulate lambs, and you can then do egg pickup on those and get and do IVF and get embryos in that way for transfer. But such a small amount of GIVIT is done that it's almost not worth discussing today in this context, but it is another reproductive technology which is out there. The main things that I will really be talking about today is AI, and then to a certain extent ET as well. Now, prior to the laparoscopic AI, there was cervical AI. Cervical AI is non-surgical. It was used to quite great effect in the 1970s, and we have somebody in the audience that has done an awful lot of cervical AI in his career. In France, there's still a huge amount of cervical AI which happens in certain regions there. I'm told by the French that there's over 1 million AIs, cervical AIs, still happening within that country today. But why don't we do cervical AI here? Because there is almost none, which happens. It's because sperm is delivered into the cervix, or the start of the cervix. You can't penetrate through the entire cervix in most of the sheep with a catheter to deliver it straight into the uterus in what would happen in cattle. So you deliver it just there, and then if it's frozen sperm, the frozen sperm can't get through the cervix themselves. So it meant that for cervical AI, you can't use frozen semen, and frozen semen is very useful from a logistics point of view to be able to do your artificial breeding. That table there, the numbers aren't important, it's just proof that frozen sperm can't get through the cervix in particularly high numbers. And that research done by this guy here, Stephen Salomon, who was considered one of the grandfathers of sheep artificial breeding, who passed away in the last couple of years, and who at the age of 99, and who would ring me up to his still very close to his death, and leave abusive messages in Latin on my answering machine telling me that I was not working hard enough and that I needed to do more work. He was a very, very impressive man, and is somebody that still has, well, actually Kelsey in the audience drew a picture of him, which is up on my wall. So Dr. Salomon is still looking down over me every single day, telling me that I need to work harder. Anyway, in the early 1980s, a laparoscope was brought to the party, I suppose. About a decade prior, almost a decade prior, it was realised that if you delivered sperm into the uterus, you would get a more efficient recovery of, or a more efficient fertilisation of eggs that had been produced. So, for whatever reason, people had come up with the idea that you could use a laparoscope, and from there, it became clear that you would get higher fertilisation rates if you used frozen semen, as you can see in that little graph. And by all accounts, the technology took off relatively quickly, and very soon there were several breeding companies that were offering this technique, and quickly more and more sheep were utilised within the stud breeding industry. Lap AI was utilised within that stud breeding industry relatively quickly. Now, this is the situation that we have today, or relatively close to today. That map up on the screen is just it's a Google map, which is available online at that website, which just shows the different companies that exist within Australia that offer these particular services. They match the major sheep growing regions of Australia. We surveyed the industry a couple of years ago, and to the best of our ability have determined that round about 250,000 sheep are laparoscopically AI'd each year, and we think around 7,000 donors. It was an industry survey, not everybody sent it in, not everybody responded to it, but that's our best guess of what the numbers are. It has previously, as the U-base was much larger in years gone by, up above 1 million AIs a year, according to people that have a lot more experience and knowledge than me of these things. I thought you might be interested to just place that in the context of some other species, just very, very quickly, it's got no actual real relation to what we're going to be talking about today, but you can see that a relatively small number of ewes, compared to the overall ewe base, are actually artificially inseminated. You compare that to pigs, to cattle, it's a much higher percentage. Now, there are obvious reasons for that, but nonetheless, it's interesting to note what some of the differences that you see in terms of genetic gains or production gains in those industries, how that might be facilitated by the fact that higher percentages of females are able to be exposed, I suppose, to very, very elite genetics. The interesting one, and now I've had to do some back calculations to try and get a good number on this, but the one that always is a surprise to people is that turkeys are all AI'd. And because they've gotten too big to actually, their breasts are too large to actually mate with each other naturally. So every single one of those is artificially inseminated, which is a whole other lecture, and it's a YouTube hole that you probably don't want to go down. Now, before we get on to the threats and the actual research, I wanted to just quickly say, because it's important when we come to talking about some of the research, that all of the artificial reproductive technologies, this artificial breeding, it is underpinned by the ability to control estrus and ovulation. Now, Graham, I think that this diagram is actually from some of your slides from many years ago, which is, at least that's what Gareth said to me in an offhand comment back when I first got my job. He passed over all of the slides and he said, some of these are from Graham Martin. So if you notice that as being familiar, that's why. Creative Commons license. What this diagram is showing you is the movement of some of the reproductive hormones within the ewe during her estrus cycle. You get ovulations which occur on average about 17 days apart. You get progesterone going up, luteinizing hormones involved, various things. The point that I want to make to you is that in order to do AI, or at least do AI effectively, so that you don't do what they have to do over in, I can't remember, was it Kazakhstan, I think that the project was in, where they were unable to get any reproductive hormones, so they just employed people to watch the sheep all of the time and have a very fine idea of when they were coming into estrus, and then they were trying to time their laparoscopic Ai accordingly. Labour is a little bit more expensive in Australia, so we synchronise our animals and we use CEDAs, which have progesterone in them, and we also use something called ECG, or what still we almost exclusively refer to as Pmsg, pregnant mare serum gonadotrophins. Gonadotrophins, they give a little kick there at the end. They're not, if I'm absolutely speaking the truth, it isn't utterly essential during the breeding season to utilise ECG to get synchronisation, but it is still usually used. It tightens up that ovulation time, and certainly during more out of season or on the fringe of season breedings, you do need that ECG. And that is very important when it comes to us talking about some of the threats, which we will shortly. The next one, this is basically what is happening inside of the ovary during the cycle. There are various follicular waves. These are little tiny follicles, and then this is follicles being selected and recruited, becoming dominant, and then undergoing atresia because there's a bunch of progesterone. In a normal cycle, it's not exogenous progesterone, it's progesterone coming from the corpus luteum, but in a synchronised cycle, exogenous progestogen's there. Now, what happens is in a superovulated ewe and a donor ewe, they get FSH. They get lots of FSH over the course of a couple of days. And what this does is allow more of the follicles to be selected, recruited. They are able to become dominant as well. At least you hope that they do. If everything goes according to plan, you get a good response and you get lots and lots of ovulations. That is a superovulated ewe. So FSH, well, it's porcine FSH. FSH stands for follicle stimulating hormone. A lot of reproduction, as I tell the students, we don't have very original names in reproduction. What does follicle stimulating hormone do? It stimulates the follicles. What does progesterone do? It's for pregnancy. And before we get on to the next bit, what is often said is, what has changed since this initial development of the technologies in the 1980s, and to a certain extent, people could argue that not a huge amount has changed. It's still laparoscopic AI. These animals are still being synchronised to an extent in the same way. It's still frozen semen. There's a few small changes that I think people have gotten somewhat faster, more efficient at doing the process. We now have semen straws as well as semen pellets. There's analgesia given to the sheep, and whilst initially, I actually don't know whether there were commercial superovulation programs with Pmsg only, but certainly to begin with, that was the way in which you could superovulate a ewe, just a big dose of Pmsg that caused certain issues. When Foltropin came around, a purified form of FSH, that did improve efficiencies to some degree. But other than these things, arguably not a massive amount of change. So now that we know what is currently happening, let's think about the future. So as I see it, these are the threats which we face within sheep artificial breeding. I think that there is an innate risk that we don't have a non-surgical alternative to laparoscopic AI. Essentially it's an elective surgical procedure which for the majority of people, at least that I know in my day-to-day life, don't see as being problematic. But we all know that there is a segment of society that would find that problematic. You're doing a surgical procedure. I certainly see it just in the 10 years that I've been teaching. Students change in how they respond to us talking about doing a surgical procedure to enable us to artificially inseminate sheep. What happens if at some point it's banned? Suddenly we can't use frozen semen anymore because we have no way of getting it into the uterus. So I see that as a threat. The Pmsg issue is a big one, and it has come to a head a couple of times in recent years. There used to be Pmsg production in Armidale in New South Wales. There isn't any longer. There are a couple of options on the market for Pmsg, and then suddenly there was none. You couldn't buy Pmsg for love nor money, and artificial breeding colleagues in the room will remember that as being a little bit of a stressy point, I suppose. It seemed to be solved in that another company was able to bring in some Pmsg, but even towards the end of last year, there were supply issues again, and we were getting phone calls from all different places saying, do you have any Pmsg in your fridge? A program, sire evaluation program needs it. Could you spare 50 doses? Anything. So it's a risk. We'll get to Pmsg and why it's a problem a little bit later, but it's produced from mares. You see online, I won't repeat some of the things that I don't want to give it oxygen, but let's just say that the production of it has raised enough ethical issues in various parts of the world that in the EU, it can still be used at the moment, but it can't be produced. And I think there are problems in even buying it legally now. There are companies within the EU that will no longer sell it, even though they can gain access to it. It's becoming a bigger and bigger issue. If we suddenly have no Pmsg, what does that mean for the artificial breeding industry? Now, the last one is a little bit more clear-cut. The last few years, there's been more of a, well, there have been many anecdotal reports that success rates of AI and ET, but of AI have been declining. And from talking to different producers, it seems to be to the point that folks are considering, well, we're not going to do any artificial insemination anymore because it's too expensive and we're not getting good enough results. That is a bad thing from a genetic gain perspective if you think about the entire industry. We don't understand really why that would be. There also isn't really any data on whether or not it's real. I think it might be real, but there's no data which says that. It's just people saying that there is a problem. There's enough that are talking about it now that I think it is a problem. But with this anecdotal decline, yes, does it mean that there's going to be waning adoption? What sort of impact does that have? That's sort of where we're going. And when we think about what is at stake if we suddenly are unable to do AI or ET anymore, well, this equation up here is sort of, I guess, a scientific explanation of what we would lose if we were unable to do undertake these artificial breeding practices. We lose the ability to be very intense in our selection. We reduce the response to selection that we have because this intensity of selection declines. And that's a bad thing. Okay, we'll talk a little bit about some of the research that I think it's mainly been an I Love Me presentation. This is what today's one is. What has my research group been doing, rather than speaking too much about what others have been doing, but I hope that you do enjoy some of it. So when we think about an alternative to laparoscopic AI, what immediately comes to mind is cervical AI. It's somewhat more palatable to people because it doesn't involve a surgery. There's not a hole being placed into an animal. But as I've mentioned before, the problem with cervical AI is that you cannot use frozen semen. It can't get through the cervix. However, one of my PhD supervisors did some work 20 plus years ago now, which showed that sometimes, not all the time, but sometimes if you add seminal plasma, which is the acellular component of semen, you are able to recover the ability of frozen sperm to navigate the cervix, which is pretty cool. But it's only sometimes. That has been attempted to be replicated around the world, and occasionally it works, and occasionally it doesn't. And we'll get to why that might be in a second. But to take a step back and think about the relationship of seminal plasma to fertility, particularly in sheep. So seminal plasma is produced by the accessory sex glands. So think seminal vesicles, prostate kind of thing. Depending on the species, depends on where most of the fluid comes from for that seminal plasma. Now, if we think about what happens to a sperm after it's made, when it's made by the testis, it's infertile when it's initially produced. It's infertile and it's immotile when it comes out of the testis, and at the head of the epididymis, if If you put it with an egg, it's not going to do anything. So that's what I mean by infertile. You can inject it into the egg, but that's another kettle of fish. So here you can see motility up the side on the y-axis, and along the bottom here is epididymal segment, with 10 being down towards the tail. So this is after passage. And that's interesting. That's motility and that says fertilization. Oh no, they're the same thing. All right. It's okay that they're both on there because it sort of matches. It's pretty similar. So as you go further down the epididymis, the ability of those sperm to fertilise an egg and their motility increases. But at the tail of the epididymis, you take sperm from there and you place it into the uterus of a ewe, completely fertile. It's no worries at all. Which sort of begs the question, why is there seminal plasma anyway? Is it really needed at all? And we were interested in that question, partly from a basic biology perspective, but also from the perspective of I'd like to know more about seminal plasma and what is its role in fertility in the sheep. So we went down the path of testing the hypothesis of, does seminal plasma have anything to do with cervical transit? Is it the fact that it is sperm being exposed to seminal plasma potentially so that it has the correct interaction with the female within the vagina and within the cervix? And so we did, we probably threw a bit more technology at it than what we really needed to, but there was a cool new imaging technique available at the time with our collaborators over in France. Might also have been just an excuse for me to go to France. But we used something called probe-based confocal laser endomicroscopy to look inside of the uterus at live sperm swimming around after they had been cervically inseminated. And we compared the number of sperm at the uterotubal junction and in some other spots, but the U2J was sort of the most interesting. Were there more sperm or less sperm at the UTJ if you had been inseminated with fresh or with, not fresh or frozen, with epididymal or with epididymal sperm plus seminal plasma? I think from memory actually it was, these animals were, we got ejaculated sperm from them, then they were killed and we used their epididymal sperm after that. So we didn't just do the cool imaging, which did actually show that ejaculated sperm, as expected, do get through better, but we also saw that motility and velocity are the same between the two groups. So this seminal plasma, which is the only difference between the epididymal and the ejaculated sperm, the seminal plasma is not having an effect on the motility or the velocity, but it is having an effect on the sperm's ability to get through the cervix. We then did a fertility trial where we looked at the same treatments, except it was epididymal plus seminal plasma. We didn't kill the animal after collecting it, and we saw that for sperm delivered directly to the uterus, there's no difference between those two treatments, but if it's delivered into the cervix or just at the start of the cervix, then you do get that big difference. So there's a big difference in fertility. As to why it was happening, what was causing it, what was in the seminal plasma which was causing that effect, we saw that at that point we didn't know what it was, but we did know that we were getting increased mucus penetration. We saw that the glycoproteins on the surface of the sperm, which sort of, they govern the interactions between the sperm and the rest of their environment, they were changed by adding seminal plasma. And what was really cool is that we saw that sperm's ability to interact with the immune system of the female changed as well. So if you were an epididymal sperm that had not seen any seminal plasma, when you were introduced to neutrophils from the female, those neutrophils got all of those sperm. They send out these little nets, basically, and they captured all of the sperm. If you expose those epididymal sperm to seminal plasma, it was like they'd been given an invisibility cloak and they were able to get through without being captured by these neutrophils. We thought it was cool. It was pretty awesome to see those things underneath the microscope. Anyway, we of course needed to know more than just, adding seminal plasma. We wanted to know what it was within the seminal plasma, with the idea being that if we could get a particular protein, then we could put that protein into semen diluents or what have you, and we would then be able to get better results. So we did quantitative proteomics on epididymal sperm and on ejaculated sperm, and we found that there were only a couple of proteins that were different between the two groups. We expected there to be a huge difference, but it was only a couple. And we took one of those, BSP1, and we started to look at the effects of that on sperm. So it was getting towards the end of our research project, and we saw that we were getting better post-thaw motilities, we were getting better velocity with this, and we then, though, needed to show some results to AWI of, let's put your money where your mouth is, inseminate some sperm that has been exposed to these BSPs and show us that you have solved the problem and that you're getting cervical transit with sperm that has been exposed to these BSPs. Now, I haven't presented a graph, it's more of an emoji. Those were our results. It didn't work. It didn't work at all. None of them got pregnant. It was very disappointing. It was crushing, actually. There's a host of reasons why it might not have worked. One of them just being that it's very difficult to guarantee that the proteins that you've purified still have activity. But it might also be that there are other proteins acting in concert. We don't know. That was the end of the funding. There's a couple of proteins left that could be explored or added together. There's a lot more work that will be done in that area. We just need to convince somebody that it's still worth pursuing. That is where we're at on the alternative to laparoscopic AI. There's some work that's been going on in Europe the last couple of years on changing the female's cervical mucus environment, and they're getting some improved results that way. Now, just quickly talk about alternative to Pmsg. Now, I won't talk about all of those details. I'll just tell you that Pmsg has a very long half-life inside of the female, and that's very useful when it comes to delivering it, because it means you've only got to give one dose, and it has a long effect. There's only one slide for this particular point, and it's that we have a couple of grants that are under review at the moment, which are our attempt to move away from having to deliver gonadotrophins to cause a change in ovulation rate of sheep. I can't go into a lot of the details because I'm not allowed, but one of them is linked to these, they're called oocyte growth factors, and basically what these do is they change the expression of FSH receptors, which is sort of how the things that the FSH acts on. And what these things do is that they limit the number of follicles that can undergo recruitment when you expose them to FSH. So if you play with these levels, you can change the number of follicles in the ovary which are responsive to FSH, which is pretty cool. You can have the same level of FSH in the animal, but a lot more follicles being recruited, and you get a much higher ovulation rate. This is actually kind of what happens naturally in Borula merinos. It's the same sort of thing, but this is just an artificial way of doing that. The other one is there is a new target which has been discovered by a collaborator of these guys here. I should say that this is Monash Uni. I'm the stupid guy that's just able to help organise sheep to do some trials. All of the IP around this and the ideas come from particularly this lady here, Kelly Walton. They're inhibin biologists, and they're doing some incredible work with mice. We met at a conference at, some people might know, SRB, got to talking. Turns out what they're doing in mice just understanding the basic biology has potentially an incredible impact in the animal industries. Anyway, they have a collaborator over in Canada who's found a new target that they can drug, which they've shown superovulates mice. And we just want to test it in sheep to see whether it works the same way. It allows the FSH levels of the animal to be dramatically increased and superovulation to occur that way. We would love to be funded so that we can actually do this work, but if you're thinking about what does the future look like for sheep artificial breeding, what are some changes that might occur maybe in the foreseeable future, we may no longer need Pmsg and FSH. That's my hope. Okay, I said I was going to try and be finished by 6. Maybe indulge me till 6:05, just so that I can do point 3. And I won't talk about sex semen at all. I've spoken to you about these anecdotal reports of reduced AI success, and every single person in the sheep industry has an opinion on what it is caused by. An AI program, and even more, an ET program, has so many moving parts. There are so many things that you can stuff up, and we see that every single time we give our veterinary students the responsibility to program the animals for their own practical classes. It's very rare that you'll ever get an animal that's ovulating at the time that it should be ovulating at. But even when everything is done right, there are so many variables on the female side and on the male side that it's almost impossible to pin down what causes a failure, or why sometimes you get an absolutely rollicking success. We surveyed the industry a few years ago, and they have their opinions on what the causes are. I think really we don't know. We don't know what they are. And I don't think that we're going to find out the results by going about things the way that we've always gone about them. One of the things that we'd like to do to address the male factor in fertility, or I should just say fertility or infertility, is by looking at semen standards and looking at semen testing again. So these are the current standards as they exist. There's not a huge amount of data linking those standards to fertility outcomes, and since those were agreed upon, there's a lot of new semen tests which are out there, and we don't know how well they are linked to fertility. So we have a project which has been funded by New South Wales Stud Merino Breeders Trust, and with input from Merino Sire Evaluation Association, which has every single sire that is going into the AMC programs for the next 2 seasons. We will get additional straws or pellets from each of those sires for us to throw as much as we can at them. It's a bit of a fishing expedition to see what correlates with fertility, and whether or not we should have a new sort of minimum standard, or whether there should be other things like, take one, DNA integrity as an example. Should that be a standard test or not? So that is the male side of things, but we'd like to take this further and look at the female side of things as well. We'd actually like to take it industry-wide beyond just the pilots that we've been doing. So what we have here is, I actually have one if anybody does want to have a look at it later on, with a company, Graaf Innovations. They're linked to BCF Ultrasound. It's the same person owns both companies. And what they would originally set out to do was to design a piece of hardware that improves the capture and display of information at pregnancy scanning. Well, we got to talking a little bit, and we thought that it would be great if we could have another piece of software written into that to potentially capture information at artificial insemination. And so that is what that little box is. It's still in beta testing, and you can certainly collect all of these pieces of information without needing any of this software or any of this hardware, but it's just something which would potentially make it easier. Wayne and Harry have been doing it through a different means, and I've been very lucky to test my system, or our system, it's not just me, with them and with a few other stud operations around the country. But you can see that what it does is just enable information about sire, whether it's fresh or frozen semen, what was the dose of Pmsg, what was the AI time relevant to when CEDAs were pulled. We're capturing information about uterine tone. I was just trying to think of anything. Uterine tone, internal fat score. Is there anything which potentially links to fertility? Does it have a predictive? Does it have any ability to predict success? Could we move to a situation in the future where we were able to almost live model the success of your program based on environmental conditions, where you are, what sort of genetics you have, what size certainly you're using, that kind of thing. That's what we're sort of thinking about. This is the other side of it, is that we're hoping to roll this out to pregnancy scanners to just utilise to improve the way that they get data, because there's a lot more fetal ageing and whatnot that happens now. Their systems just don't have the ability to capture any of that. What this system does is it automatically marries up all of the information so that producer gets a report sent to him immediately afterwards, as well as the AI company on how well they've done, how well the different sires have done. We could potentially use it to look at things like rainfall, thunderstorms, humidity, goodness knows what. I'm not going to talk about sex semen because I don't have time, other than to say this is what my PhD was on. We've done a couple of projects with AWI in the last couple of years, which enabled us to take, this is post-thaw motility of what was being produced by industry. It was around 0% up to almost 80%, which is probably the biggest difference between two treatments I've ever seen in my life. We're very happy with that. Same goes for the liquid results, but we were able to get quite decent fertility with the sex semen, at least for chilled samples, and it's since been commercialised, which is probably going to be my biggest achievement, other than producing children, in my scientific life is that there is a reproductive technology out there that we were around for and enabled development of. They're getting good results at the moment in all of the work which is being done. So to conclude, I would say that the points that I was trying to make today were that there are threats to artificial breeding, unfortunately. It would be lovely to just keep going along as we have, but it would be wise, in my opinion, to keep these in mind. That it would be wise to try and address them, if at all possible. And if we think about what the future of sheep artificial breeding looks like, one day in the future, might it be possible to do cervical AI with frozen semen? Maybe. Would there be a situation where we could just have, where we didn't have to use Pmsg or FSH, no more gonadotrophins? You've got to remember that these are coming from other species. It's, you know, you're putting pig and horse stuff into a sheep. At some point, people are not going to be happy about that, aside from all the ethical perspectives. I would hope that through some of the research that we are doing that we will be able to get more predictable and better AI and ET results. I hope that semen standards improve, that there's going to be better labelling for one, but that we have a much, we rule out some of the really bad semen which is out there. And I would hope that when we look at the future of sheep artificial breeding, that we have an environment where data collection and the ability to make decisions based off that data is something which is much more commonplace and embraced. In the same way that it seems to be in the US for the dairy industry. I know that it's a very different industry. I know that just the way that dairy cattle are and how often you see them means that it's easier to get that data. But you know, over there, the artificial breeding companies are able to track individual ejaculates through the system so that they can recall semen if they start to see that there are poor results coming in. Or they know that they need to start boosting the number of sperm in the semen straws that they push out because they're seeing a little bit of a dip. They have that kind of real-time information. None of this is going to happen overnight. It might never happen, but this is the sort of stuff that I think would be cool. The overall goal, of course, is to improve the results, and whilst it sounds very trite to me and the sorts of work and the work that I do, I want this industry, the sheep industry, to have the ability to keep being able to seek that genetic change, that production change, so that their production and their future is secured. That's why we do the work that we do. And I hope that it continues to make some sort of a positive difference. Many people to thank. A couple that I will point out. Those two blokes in the picture that had the sheep upside down in front of them, Chiz and Graf, they are responsible for my career, and I'm very grateful to them for everything that they have done for me. My main postdoc, Jess, apparently I speak of her when I get up at presentation. I'll say, I'd just like to thank Jess, who has been with me since the beginning. And people go, oh, they're married. I didn't know they were married. We're not married, but she has been an incredible postdoc and has a huge future. Xavier Drouard has been a big one on the proteomics side. And then I would like to thank, in particular, the people who are in this room have been a big support to me and are a big support to the sheep industry. Harry Wilson and the Button family, of which Wayne is here. They do an awful lot to support our work. Thank you very much for your time.
Thank you, Simon. I will take the two questions. We'll take time. So, please, who wants to ask? First question. Graf.
I mean, this philosophy of fertility in AI program, we've had a lot of news in recent times about the decline of human semen quality. Is there any evidence that those sort of issues are happening in the ground? Is there DNA damage accumulating now that kidney damage from years ago? Are there potential environmental factors?
Yeah, it's an interesting question, and it's one which I don't think it was funded, but there was a grant I know that or a project I know, because I'm friends with the person that submitted it, under consideration at least, that was aiming to look at whether or not the things that have been observed in human reproduction for the male, that you've just spoken about, whether any evidence of that exists, not just in our livestock species, but in companion animals as well. I don't think there's any real data on that. We haven't seen, I don't know, you could probably speak to the artificial breeding guys whether they've seen an obvious declines in quality of ejaculates. I think probably not. I don't think that there have been, suddenly much smaller testes or less sperm, but it is something that we wonder about, particularly with the whole endocrine disruptors being a big issue of late. Yeah.
Sean, what does freezing do? Does it take sperm back to an epidermal phenotype, or what's going on?
Yeah, so it's an interesting one in that so freezing causes a lot of sublethal damage, and it seems to advance the maturation of the sperm as well. But what I didn't show was that oftentimes we would look at frozen sperm as well, and occasionally you would see some of those things, like when we're looking at the glycoproteins or whatever, it would match the epididymal phenotype. But other times, no, it would go in the complete opposite direction. So it doesn't seem to be. It's not so clear cut. What we were really hoping for with the BSPs is that it was going to be simple because you have no BSPs, almost none, in the epididymal sperm. You have lots in ejaculated sperm, but then in preserved sperm, you actually have a lot less BSPs because egg yolk sucks out the BSPs. They really preferentially bind to those. So that was going to be a great story. It just didn't work out that way.
Jane?
Just a something probably minor question. Why is there not bovine somatotropic?
There is in New Zealand, or at least there was. I don't know whether it's still available, but yeah, I don't know why that isn't. Well, I know why it's not available in Australia, the New Zealand product, just for quarantine type reasons. But I don't know why it hasn't been. I presume that it's just too expensive to make. But I don't know. Do you know, Graf?
I think you're right. I mean, European, well, in Europe, they decided not to do it because it's a really small part of their market.
Yeah.
I think because it's expensive, because they saw heck of the issues on the way.
Yeah, there's one there. Yeah, it's
What about different breeding technologies for the sperm? Like, some of the technologies we're using in the seafood industry. If they use different technologies for the freezing of the sperm, would that affect the capacity to use the sperm for the cervical ai?
Yeah. Yeah. It's probably been like, I don't know how many PhDs have been thrown at trying to improve the quality of frozen sperm. The thing which I should say that that isn't perhaps evident from what I've presented is that frozen sperm, it's very obvious the difference between frozen sperm and fresh sperm. It's like their motility is probably halved. There's a whole lot of other things which are altered about them. To some extent, it's not surprising that they would be different in how they interacted with the female. What is weird is that liquid stored sperm, so it's a sperm which has been it's been collected and it's just held fresh for any time over 12 hours, still has the same motility. It's up at like 90%. Velocity is exactly the same. Almost anything that you analyse it with, it looks identical to the freshly collected sperm. It's still lost its ability to get through the cervix. So there's something really subtle which is occurring to the sperm surface, presumably, because there's nothing about their movement that we can pick, which is changing their ability to interact normally with the cervix. The theory that we have is that it's the immune system, but it could be something like, you change the types of proteins which are on the surface, which changes the charge of the sperm, which means then when it interacts with the mucus, which it also has negatively charged, it all just doesn't work. But, yeah, a lot of different freezing technologies thrown at it, and you can get improved motilities, viabilities, but even if it looks good in vitro, it's not playing out as an improved in vivo response, which is always really disappointing.
Salomon, is there any known reason why the goat cervix opens at the time that we want to visit the insemination where it chooses? Is there any known reason?
I mean, just from looking at the cervices themselves, it appears as though most. I don't have a lot of personal experience in working with the goat, so I can only go off from what I've seen. It appears as though the goat cervix anyway, for the most part, is a bit more open. It's not as tortuous, so that when changes do occur at estrus and it becomes a bit more open, in most of the breeds you can get a catheter through and you can do intrauterine, transcervical intrauterine like that. There's been quite a bit of work over the years that's gone into trying to deliver different products to the sheep or directly to the cervix to try and open it up with fairly limited success. Prostaglandin E, I think a variety of prostaglandins, relaxin. There is a paper where they've rubbed cocaine onto the cervix. That didn't work. Apparently it was a great field trial though. Lots of different things.
Jane, one more, please.
Can I just ask one curious question?
Yeah.
So I do a lot of work with pregnant ewes, and the time of removal of the sponge versus introduction of the ewe, we have a theory that it influences whether we get males or females out. Is there any way that we can manipulate, or are you aware of any relationship between the timing of the start of ovulation and when the ewes are rams are introduced, as to whether you get males or females?
There was a method, I think it's called the Shettles Method in humans, that if you timed sex with ovulation appropriately, you could influence what the sex of your offspring was going to be. Sold a lot of books, but I don't think that it was ever proven beyond a doubt that actually worked. I'm not aware of anything that is robust enough in that area that you would regularly get the results. So the thing is that with sex ratios, you do see these weird skews from time to time, but oftentimes it's just because you don't have enough animals to really to get a statistically significant sort of effect. It's just by chance that you saw that that skew that time. There has been work on, I think, level of omega-3s or polyunsaturated fatty acids in the feed that seems to have a shift, or it does cause a shift in the number of, I think, females born, but only works on certain properties, which is problematic. So for the time being, I think that we just have sex sperm by flow cytometry. I don't think that it is likely that you can influence sex by altering the time of AI, because there's not very much difference in the swimming speeds. In fact, I don't think there's any difference in the swimming speed. I think there was a difference shown in one study in the amount of straightness between male and female sperm. And when, that, I realise we're getting quite late, but in that video that I showed you of inside of the uterus, there is all of that movement. That's not me moving it was me trying to hold it still. It's all of the contractions that are happening, and there is so much movement which happens just from the female having muscular contraction, that the tiny differences maybe between sex of the cells, I don't think it's going to cause a difference. That's just my opinion.
Thank you. I think, would you please join me in thanking Simon for his very interesting and insightful lecture, again translating from the basic research into application, and spending 2 days of your life with us, traveling all the way from Sydney during this course. Thank you, Simon.